Let us consider the next problem. In this problem, we will create a program that takes a string input and creates a Caesar ciphertext by shifting k letters, where k is set 3 here. Let us name this program enc.rb. Suppose you execute enc.rb with Ruby. Then it will wait for the characters to be entered. So if, for example, input God like this, then you get grg, which is obtained by applying 3-letter shift only on the lowercase letters. This is the type of program that we would like to create. Let us first consider the outline or the idea of the program. The program will first read a string such as God, which is stored in, for example, the array M. Then the character codes will be calculated. We put them in an array called A. And then these codes are shifted by k. In this case, k is set as 3. That is to mean to shift each lowercase characters by 3 letters. These shifted codes will be placed in the array B. Then the program will transform codes back to characters and store it into the array, say C. Specifically, the program will look like this. Let us consider this program following these steps. The program starts with this preparation part. First, like before, we memorize in the variable code_A the code of letter A in ASCII, which is 97. Then it should be remembered that the shift number k is 3. Then, to start with, the string of characters, that is, a message to be encrypted, should be read into the array named M. By the way, M stands for message. Then the length of string will be calculated and entered into variable length, meaning length. Now we move on to this part for creating a ciphertext. We first use this unpack command to transform the string M, that is the array of characters, to the array of code numbers and store it to the array A. Then next, this is the important part. We will be calculating the codes by shifting by +k and store them to the array B. Note that we need to prepare the array B in advance before this point, which is done by this statement. Then the obtained character code in the array B will be converted back into a string. For this, we use a command called pack. This should create your ciphertext. Then program ends by showing this obtained ciphertext onto the screen. Now, how do we approach the calculation in which you shift the codes by k? Let us give this some thought. For example, you have A, B, C, D, E. Then let us, for example, look at D. And then you shift by 3. So 3 letters from D is E, F, G. And G is a letter corresponding to D by 3 shifts. In the same way, you will have D, E, F. Okay? A corresponds to D, B corresponds to E, C corresponds to F, and such. For this type of shift, it is useful to consider character codes. For example, this code is 100 in ASCII, so if you shift by 3, by adding 3, you will get 103, which is the character code corresponding to G. Okay? So this is how calculation is done. However, you do need to be careful here. The characters towards the end, such as W, X, Y, Z, okay, these are somehow difficult ones. Okay, in fact, W does shift to Z, but X becomes A, and Y becomes B, and Z becomes C. Okay? This will be easier to comprehend if you consider the alphabet as a loop. For example, consider Y. Okay? 3 characters ahead of Y would be B, because 1, 2, 3, right? As it loops as Z, A, B. So Y would correspond to B. The character Y would correspond to B. Therefore, this character code becomes 98. So then, how do we compute this? As mentioned before, let us consider now the distance, that is the distance from letter A. These are distances from the code of A. For example, the distance A from A itself is 0, the distance of B from A is 1, and distance of C from A is 2, and so on. Note that this distance can be calculated by decreasing the code of A, that is 97, from each letter's code. For example, the distance of D from A is calculated by 100 minus 97, that is 3. If you think this as such, then shifting by 3 means adding 3. For example, this distance 3 becomes 6, like this. Okay? And note that we can go back to the code in ASCII by adding the code of A, that is 97, to this distance. That is 6 plus 97 becomes 103, which is the code of the shifted character, which is indeed the letter G. Then let us consider the letter Y. Its code is 121, so by subtracting 97, we get 24, which is the distance from A. Then what do we mean by adding 3 to this 24? Note here these numbers, the distance from the letter A is at most 25. So after 25, the distance should go back to 0. So from 24, we should proceed 25, 0, and 1. Thus, we should get 1 by adding 3 to 24. And by adding 97 to this obtained number, that is 1, we get 98, which is the code of letter B, the letter that we wanted to obtain from Y by 3-letter shifting. What we need to do is the addition of this type. As we follow this way, the result becomes from 3, 4, and so on, up to 25, and then what comes after 25 would be 0, 1, 2. What sort of addition are we considering here? It is illustrated like this. We add 3, okay? But if the result becomes 26, it goes back to 0. Okay? Have you think of what it is? So I think you have got an idea how to conduct this addition. Let us actually program this. But before moving to the actual programming, let me give you some tip of executing a Ruby program on the terminal.